Okay, so once again, we are in vector quantities, and that is for the part D of the review for the physics part, which is the basic mathematical techniques in formula manipulation. Now, I just want you to remind that if you are looking for the other topics that is included, you can find it here. So right now we will be discussing the vector quantities. You could click the lecture video and the sample questions as well as the physical worksheets. Okay, so let's start now. So from the last time, I discussed about the scalar quantities. And this time, I will emphasize now the vector quantities. Vector quantities are described by magnitude and direction. One example for that would be displacement, which is, you can see here, there's a magnitude 5 kilometer, and also there's a direction, which is north. Another one would be velocity. We have 25 meters per second, and the direction is east. Another one could be like a force, which is 20 Newton, 30-degree north of east. So those are all examples of vector quantity. We have the unit of magnitude, and we also have direction. So examples of vector quantities, it includes displacement, wherein the unit is in meter, velocity is in meters per second, acceleration is meter per second square, force is in Newton. By the way, these are just another terminologies regarding force or another type of force. You might encounter weight. That is the unit for that is force. We also have a drag, which is also a force. It is usually the friction coming from the air. We also have the thrust, that is for the mechanical movement of any flying objects. For example, the airplane. We also have the friction, which is also a force, and then the unit of that is in Newton. You don't need to uh you don't need uh to study well about the calculations of this right now, simply because we're still gonna tackle that on the next topic of forces. So as of now, I just want to emphasize that you might encounter this weight, drag, thrust, friction. All of these are forces. Now, for momentum, we we have kilogram in meters per second, and for the impulse, we have Newton seconds. And again, we're gonna tackle this on the next topic or in the next video. So note that these scalar and vector quantities are different when asked in examinations. And we should be careful of knowing what is being asked in the question. Say, for example, here we have the distance. For the distance, all lengths are added regardless of direction. Okay? So later you're going to see that on the problem. Okay, so for the displacement, we have to define it from the start point to the end point. So usually, we need to distinguish the answer for what is a distance, what is a displacement. And of course, for the speed, the definition of speed is distance per time, where for velocity, the definition for that is displacement over time. So there's a big difference between speed and velocity, as well as a distance and displacement. So we also have this acceleration, forces as our vector, and then we know that the acceleration has a unit of meter per second square, and for the force, it has a unit of Newton. Now, most of the time, students are confused with the terminologies, which is mass and weight. When we are in chemistry, we sometimes don't really give emphasis on the difference between mass and weight. But when we are asked in physics, we we usually try to express mass as a scalar quantity, and the unit for that is kilograms or grams. Okay, but of course the SI unit for that is grams. Okay, the SI unit for that is kilograms, not grams. Okay, so but anyway, they have the same values. Okay, they have the same unit. Okay, they're all referring to mass. Now, how about for weight? Weight is different in physics because it is a force, and the unit of that is Newton. In fact, we need to be very careful in the definition of weight because that is mass times gravity. And so the formula for that is weight is equals to mg. And the unit of that again is in Newton. Okay? Again, weight is a vector quantity. It is a force. Well, mass is a scalar quantity, and the unit for that is kilograms. So vectors can also be represented in one dimensions or two dimensions. Okay, so what do we mean by this? One dimension, two dimension. We usually, when this type of question is asked in the exam, they are usually referring to one dimension. Okay, what is this? It could be the north and up, north and south, or up or down. Or it could be east and west, or left or right. So for example, a bike travels 10 kilometers north, then goes back 6 kilometers south, then travels north again at 2 kilometers. The overall trip is 2 hours. What are the first distance? So when we ask for the distance, we just simply need to add it. That is simply add all the lengths, 10 kilometer plus 6 kilometer. That would gonna be 16 plus 2 kilometer, and the overall for that would be 18 kilometer. So that would be the distance. Now, how about the displacement? For the displacement, we will gonna represent 10 kilometer as negative 10, and then we will gonna add up with 6 kilometers south as negative 6. So that would be minus, and then plus 2 kilometer north again. So that would be 10 minus 6 is 4 plus 2. So that would be 6 kilometer. Now, if you will gonna try to imagine this for the displacement, that is 10 kilometer north, and then it goes back 6 kilometer, uh, 6 kilometers south, and then another 2 kilometer north. So overall, if you're gonna try to imagine this, so this one in one dimension is uh 6 kilometer headed towards north. I think it should be in the north direction, right? It should be in the, not in the east or west direction. I think it should be in the south and north direction. Let me just write my illustration here. So once you say displacement, it is from the starting point. No? So we have 10 kilometer going up, and then 6 kilometer going south. Think this one is a better representation, and then another 2 kilometer. Okay, so overall, this is the displacement. Okay, so this one is the 6 kilometer. Okay, now how about the average speed? For the average speed, that is, if it is overall 2 hours, that is distance over the total time, and that would be 9 kilometer per hour. However, for the average velocity, that is 6 kilometer divided by 2 hours, and that would be 3 kilometer per hour. But this time, it will gonna head towards the northern part. Okay? So that would gonna be heading towards north. So this is the difference, okay? Now, let's try to answer this one and try to pause. Don't look at the answer here, or try to, if you look at already, if you already look at the answer, kindly look why is it, or prove why is it that the answers go like this. So a man runs 5 kilometers east, 10 kilometers west, and another 1 kilometer east for 4 hours. So just try to look at the man's distance. For the man's distance, the 6 is simply 5 plus 10 plus 1, right? We don't care about the direction. So that is just 16 kilometers. Now, how about for the man's displacement? For the man's displacement, this one can be represented as positive 5. And then the west is negative 10. And then this one is another positive 1. Okay? Okay, so this one is 5 minus 10 is negative 5. Plus 1. Okay, so negative 5 plus 1, that would be negative 4. And so that would be negative 4 kilometer heading west. Okay, the negative 4 kilometer, or that would be 4 kilometer heading west. Okay? Now, how about the man's average speed? For the man's average speed, very simple. Simply because 16 divided by 4, that would just be 4 kilometer per hour, right? So this one is 16 kilometer over 4 hours. That is 4 kilometer per hour. Now, how about the average velocity? For the average velocity, that would be negative 4 kilometer divided by 4 hours. So that would be negative 1 kilometer per hour. That would be the average velocity, because remember, once we talk about average velocity, the definition for that is displacement over time. So there's a big difference between the calculations of distance, displacement, average speed, and average velocity. Now, let's look at the example for our one dimension. We usually, for the one dimension, for the two dimension, in entrance examination, we use two dimension in the form of x and y, and more often the combination of vectors are heading towards north and turns east. And in this example, we will use the Pythagorean theorem principle. So let's look at this example. A dog walks 6 meters north, then turns 8 meters east for 10 seconds. What is the distance? For the distance, it's very simple, right? That would be 6 meters plus 8 meters. That would be 14 meters, right? That is for the distance. Just simply add it. We don't care about the direction. Now, for the displacement, it will be different. Why? Because it will gonna have 6 meters going north, then it will gonna turn 8 meters, right? And so this one will gonna resemble from starting point up to the end point. The displacement will gonna resolve into a into a right triangle. And so we all know that if it is a right triangle, we have the Pythagorean theorem. Okay? And so from this, if you know the Pythagorean triples, that would be 6, 8, and the 10. But if you don't know the Pythagorean triples, by the way, I would like to give a tip here. Most of the time in the entrance examination, you will not gonna have like you will not have calculators. So therefore, you must at least memorize the Pythagorean triples. Okay? So what are those? 3, 4, 5, 6, 8, 10. There are other Pythagorean triples. Okay? You're going to tackle that in math. Or you can search that in the internet, Pythagorean triples. Okay? So, so from here, we have now the Pythagorean. So for the displacement, it's 6 squared plus 8 squared, and that is 36 plus 64. And that is 36 plus 64, and that would be square root of 100. And that is 10 meters. Okay? Now, how about for the direction? You need to review the trigonometry part, but this is the general formula. Arctan is equal to summation of y over the sum of x. So add all the y and then add of all the x. So in this case, what is in this case, what is the value of the y? I think so there should be like correction here. So what would be the value of y? So the value of y is arctan. That would be, what is the y here? The y here should be 6 over 8, not this 8 over 6. So you need to be very careful on that. Okay? So, and if we're gonna press our calculator, let me just press my calculator here. What is arctan 6 over 8? And so the value of arctan 6 over 8, if we're gonna press our calculator, that would be 36.87 degrees. So 36.87 degrees about x-axis. Okay. So again, we need to be very careful on that. So that would be the summation of all the y's and the summation of all the x. So note in the exam, this answer may leave as it is since you will not use calculator. In case you press your calculator, the answer should be 36.87 degrees. Okay. So far, the magnitude is 10 meter and the direction is 36.87 degree. Okay, I would like to emphasize that be very careful on the summation of y and all the summation of x. Okay, Now, how about for the average speed? For the average speed, that is distance over time, that is 14 over 10, that is 1.4 meters per second, right? And then for the average velocity, let's look for the average velocity here. So that would the displacement is 10 meters. And for 10 seconds, that is 1 meter per second. And then again, 1 meter per second, the direction is 36.87 degree above x-axis. Okay? Or that would be 36.87 degrees north of east. Okay, we're still gonna tackle this on the other lesson. Okay, and that's it for the vectors. Now you may want to answer the practice sets. Okay, you can pause the video and answer this practice set 1, practice set 2, practice set 3, practice set 4, and practice set number 5. And the discussion is on the link on the on our Google Sheet platform. Okay, so you can try to click the link, and they will direct you. It will gonna direct you on the discussion of this practice set. Okay, so that's all. Thank you very much for listening.